Hello and welcome to today's SMPTE webcast. As you can see, the topic is ACES 101, a standards-based color management workflow. I am your host, Joel Welch, SMPTE's Director of Education, and we will quickly go through the housekeeping slides. As I said, I am Joel Welch, SMPTE's Director of Education. We do have three sponsors for this webcast. They are VizRT, AJA Video Systems, and Signient. I want to thank them for their generous support and allowing us to bring this webcast to you free of charge. Also wanted to take a minute or two to let you know that anybody who participates in this particular webcast today can receive a 10% discount on registration for SMPTE's annual conference, SMPTE 2020. All you have to do is use the code ACES101, or if you have a QR code scanner, you can quickly scan this. It will allow you to automatically receive that 10% off. It's going to be a very different event this year, so please consider registering. And here's a little bit about why you should. There will be a global community this year because it is a remote event. People from around the world will be there. It's your conference. There's lots of things that will be covered. Flexible and comfortable learning because there will be many different sessions going on, and the program itself is just going to be so full and so rich that you're bound to just find lots and lots of value. Also, because it is a virtual remote event, there is a price point for everybody, so everybody can afford to participate in some or all of the event. And of course, this year's theme is Game On, and we will have our regular program plus some additional networking and special educational events, but we'll also have a full day on esports. And there will be a surprise at the end of that day. Also, I want to let you know that SMPTE does offer a virtual course on understanding the digital cinema package, DCP. And the instructor is Jack Watts. He's the person who was highly involved in developing the standard, the DCP standard. And you can see the objectives there on the screen. And if you use that QR code or the code SMPTE50, you'll receive a 50% discount on the registration for that course. And it is available to members and non-members alike. If this is your first time with us, the SMPTE webcasts are monthly. Usually, lately we've been doing more than monthly. We've been doing several a month. They're 60 to 90 minutes online, interactive. That interactivity is up to you. We hope you will ask questions. That's what makes it interactive. Normally, it's a free professional development benefit for SMPTE members, and we do record them for viewing convenience. If you would like to ask a question, that's how you make it interactive. Please type into the question box, especially if you want to speak to our presenters. Say, I have an oral question, and at the time we take questions, I will unmute you. You can talk, you can ask your question, and then when you've asked your question, I will remute you. We will be taking several breaks throughout the presentation for questions. So please have your questions ready. Don't delay. If something piques your interest and you want to know a little bit more, go ahead and type your question in when you have it. So it's ready and we can ask it of the speakers. Also, we'll be providing a PDF of slides used during this webcast. In addition, in exchange for your feedback, we need to know what worked, what didn't. We also want to know about your thoughts for future topics. So please, once you submit that completed feedback form, you'll be automatically redirected to the PDF. And of course, if you participate in social media, please feel free to post, blog, tweet, whatever. And our handle is @SMPTEconnect, #SMPTE Webcast. Views and opinions expressed during this SMPTE webcast are those of the presenters and do not necessarily reflect those of SMPTE or SMPTE members. And this webcast is presented for informational purposes only. Any reference to specific companies, products, or services does not represent promotion, recommendation, or endorsement by SMPTE. And as a reminder, the topic is ACES 101, Standards-Based Color Management Workflows. And I'm going to turn the floor over to our guest moderator, Ms. Annie Chang. And Annie?
Hello, everyone.
Floor is yours.
Thank you, Joel. Hi, everyone. Welcome to the ACES 101 webcast. I'm Annie Chang, and I'm the VP of Creative Technologies at Universal Pictures, and also the project chair for ACES, which stands for the Academy Color Encoding System. Along here with Carol, Nick, and Alex, we will explain the basics of what color management is and what ACES is. Then we will talk about the current state and future state of ACES, a little bit about the logo and service programs that we have, logo service provider programs, and the ACES community. And then we'll talk a little bit about ACES and broadcast. Lastly, Joel will moderate a panel and take questions. Just so you know, we are planning to have stop and ask for questions for each section. And please note there are no dumb questions, so please ask away. So now I would like to introduce Carol Payne, who is the imaging specialist at Netflix and the co-chair for our gamut mapping working group. She's going to level set us first and take us through what color management is and why it's important. So Carol, take it away.
Thanks, Annie. Really excited to be here, everybody. And like Annie said, it's hard to talk about what ACES is without that level set of what we mean when we say color management. So what do we mean when we say color management? It's first, we're going to start with talking about what we think the goal is. And for us, that's to keep all departments aligned to a common vision by providing consistency in imagery production and creative intent. Now, those are a lot of words and it sounds nice, but what actually is it and why is it hard? Well, one of those reasons is this, the problem. With the advent of digital cinema cameras and digital cameras in general, what we started to see was something like this, which is all different types of digital cinema cameras and their recording spaces, and that they're all different and unique and adapted to their particular sensors and technology that the camera manufacturers use to make their camera the best that it can be. What that really means, though, is to manage all of that different data versus the days of film scans where you had one format and a couple different ways of doing things, some different emulsions of different ways and emulations, but this is a much bigger problem to tackle, and it's really where color management comes in and shines. It's at the beginning and the end of the pipeline. So you have this problem, and what often ends up happening is you get what I like to call lost in LUTs. And as a reminder, when I say LUT, it stands for lookup table. And it's really a colloquial term that we use in general. There's lots of different types of lookup tables, lots of different formats, but it's a way to translate pixel data, often in the form of a grade, from one type to another. And what ends up happening with all of these different digital cameras and all of these different outputs on the other side is you end up with a spider web of LUTs that is from one to the other to make sure you can get from everything into something else. And it ends up being a mess, very hard to track, and often inconsistent and not the best reproduction of the image that you could possibly have. So along those same lines, a little bit of background is that digital cinema cameras are really capable of capturing very high fidelity information from the real world. They have been through the history of cinema, including film cameras. They're high dynamic range, they're wide gamut, and our camera sensors are more than capable of capturing enough data to represent the creative intent of your image. Same goes for the our modern image containers that we use, EXR, DPX, and the raw camera formats that each camera manufacturer uses to represent their data, can hold, more data than we could ever capture, pretty much, if we wanted them to. So the problems are not the recording device, the problems are not the image containers in representing that data. We all know, though, that display limitations is where we start to have issues. Display technology, historically and currently, is just really not capable of reproducing the color and dynamic range we can capture. However, it has gotten a lot better. And what we've seen is going from one display standard, which is that SDR, sRGB or Rec 709, BT 1886, whatever flavor you'd like to call it, that one standard, what's happening now is as many capture formats as we have, we also have on the other side lots of different display standards with the advent of HDR technology. So now not only are we dealing with many variable inputs, we're dealing with many variable outputs on the other end, and it just increases the complexity again, probably tenfold by a multiplication level, and it's hard. And so what do we really do about it? Well, in our previous workflow is what we call display referred workflow, where because the displays were standardized to that sRGB BT 1886 based on mimicking the cathode ray tube technology from years and years ago, what you could do and what we did do was master to that specific display technology because it was consistent, because everybody used it. But what that meant was it results in color decisions tied to a single display. And so if you ever wanted to change that, if you ever needed to go back, it basically meant a complete redo of all of the hard work that you did in your color, in your grading suite to make that film or TV show or commercial shine. And it's a lot of work. It also limits your ability to, have the maximum amount of data that you captured in your archive. The goal would be to protect that archive for as long as you possibly can. And when you're tying decisions to a technology that's dated, you limit your workflow and your project. So what we like to do now, and what we recommend, is a scene referred workflow, is what we call. You might have heard that a lot, that word scene referred. And it's really just shifting where you make those color decisions for your project from display dependent to display independent. So you're now making those color decisions in the scene color, in that captured color. And we'll talk a little bit more. Nick and Alex will go over a little bit more about what that means in an ACES workflow. But really right now, all you need to focus on is that those color decisions are made on your captured material in the highest dynamic range, highest bit depth, highest quality that we can keep for as long as possible through the pipeline, which makes those color decisions tied to your original work and not to the display. And then at the end, you use specific output transforms, which we'll again talk about later, to get to your different displays. And it results in less duplicate work and more consistent reproduction for everybody. And that enables you, like I was just talking about, to take in all of these unique sources, put them in a unified color space that captures and preserves all of your data that you went to the trouble of capturing for your production, and make sure that it stays consistent and reproducible to each of these different output devices. And that really goes across all departments of your production, from onset looking at monitors, editorial looking at dailies, your visual effects artists working on linear scene referred data, but still needing to view it on their displays, to your grading suite where you're working on a very high-end reference monitor that's able to reproduce many more colors, to what you archive at the end of your production, and making sure that all of that is in the same space, in the same way, and each department is able to look at things and have confidence and security in the fact that they can reproduce what's correct for their area of expertise, and know that whoever's looking at it on the other side can see the same thing, including all the way up to your end viewer who's looking at it in whatever experience they're looking at it in, whether that's on their TV, on their phone, in a theater, whatever that is. This type of color management, scene referred color management, and ACES, as we're going to talk about, is a way to ensure that consistency in image reproduction and that confidence for your creatives to not have to think about all the time the technicalities of how they're going to do this and focus on the art, similar to what we would like to say the days of old in a traditional film workflow. So I think I just kind of already said this, but yeah, these goals of color management, just to reiterate, that confidence for the creative, handling of mixed image sources, and protecting the fidelity of image data. And with that, this is going to be our first stop for questions. So I'm not sure if we've got any yet, Joel.
We do, in fact, have a couple. Let's see. Chitan asks, if we use 2100 HLG PQ scene referred color space, it is wide color gamut with high dynamic range. Then why do we need ACES?
So HLG is a commonly, this is getting a little bit into the weeds here, and we're not here to say that any workflow is necessarily better than the other. ACES is, regardless of your output so your display side, which would be your HLG delivery space, that's great. But ACES also provides on the other end of it that same way to get all of your different cameras and those input device transforms, which we're jumping ahead a little bit in that, into that common scene referred working space. And then you can go and work in HLG if that's your choice or whatever. But it's just, ACES is one way of working, and we think that it covers all of the bases, but it might not be and end up being your delivery format in that display referred space, depending on what you're doing.
Okay. And the questions are starting to come in. We'll take a few more and then we'll move on, and we'll take them at the end if that's okay. Sure. Let's see. Joaquim JZ asks, when will ACES version 2.0 be released?
I'm going to push that one to the end because we are going to cover that later in the presentation.
Very good. And then let's see. Last question for this break comes from Abhay. Does ACES equal ICC?
It does not. It does not. They are so the ICC is a different form of a color management framework, which we're not going to get into this presentation. If you have detailed questions about the differences, feel free to reach out to us on ACES Central. But I guess that my answer for right now is no. ACES does not equal ICC.
Okay, and just FYI for our audience, SMPTE is exploring a much deeper dive into the technology behind and standards behind ACES. So we'll answer many of those technology questions. And with that, why don't we proceed to the next section?
Okay. Thanks, Carol. I'm going to start first of all by apologising for the fact that I've got a stinking cold, courtesy of my 9-year-old son. But I guess one big advantage of virtual meeting is that none of you can catch it over the internet. So I'm Nick Shaw from Antler Post in London, UK. I'm a workflow consultant and an ACES mentor, which means I hang out on ACES Central and try and answer people's questions. And I'm presenting, hopefully, alongside Alex Forsyth.
Yeah, I'm here. I'm Alex Forsyth, and I'm the ACES project technical lead for the ACES team.
And Alex and I are going to talk a little bit about the nuts and bolts of an ACES workflow. So as Carol has just explained, the traditional television approach is display referred. So everything is referenced to the particular display the picture's mastered on, which may often end up being a standard dynamic range display because not everybody working on a show will have access to an HDR display. So if you then have to produce different deliverables, you need to do some sort of conversion or start again from scratch. And conversions, particularly if you start from SDR, up converting to HDR can be problematic. ACES solves this by working in a scene referred way. So everything you work on is done with reference to the light in the original scene, and you're repainting that original scene in grading, as the nice little icon there of the painter's palette shows. That's what you composite in VFX, matching your CGI elements to the same light levels in the virtual scene that were there in the original filmed one. And then only at the final stage, everything is transformed from the scene referred color to the appropriate display using a transform targeted for that particular display, what we call an output transform in ACES terminology. And each person who works on the image, whether they're in different departments, different locations, different vendors, they use the relevant output transform for their type of display. And so some VFX artists might work on sRGB monitors, but the colorist might have a high-end reference HDR monitor, and they see an image which is perceptually the same, obviously within the limitations of their given display. So when you want to make a deliverable then for a different format, you switch the output transform, and all that's needed is then a trim pass to check what the image looks like in this new format. And it's just much, much quicker and simpler than regrading from scratch. It can surprisingly also work the other way around. If you made a show in SDR and you were not asked for an HDR version of it originally, but you worked in ACES, because the grade's been done, scene referred, you've preserved all the dynamic range, all the color that was in the original image. You haven't restricted it to the SDR range, so you can switch output transform to an HDR output transform, and that actually gives you a very good start point for an HDR grade, and again, just trims are needed to customize it for the particular HDR format you are delivering in. So if you work in a big facility or for a huge TV network, you may have access to color scientists who can create bespoke scene referred pipelines for your shows. But for a lot of people, that isn't an option. And even if you create a bespoke pipeline, you don't just have to create it for one system. You need to create something which will work identically across every system used by every person working on the show. ACES helps this by being a standardized scene referred approach, available to everybody out of the box in a number of commonly used grading systems. It's open source. The maths and the reference code is published here on that link address shown on the screen here, on GitHub. And by using the same publicly published set of transforms, all implementations can work in the same way wherever you find them. For all vendors and departments in different applications, in different hardware, everyone can base it on the same maths to make sure that everyone sees the same result. It is important to remember that ACES isn't just some post-process you apply after the fact. To use it properly, every step in the workflow, from sets to post to delivery, should be done the ACES way, and ACES documents and ACES configurations will guide you through those processes. Quick start guides on the ACES Central website, which will help people get started with that. For applications and systems that don't have the ACES transforms built in, it's actually often possible to add them with a plugin using something called OpenColor.io or OCIO, another open source system which allows color managed pipelines to be added to applications that don't support ACES out of the box. And Alex will talk a little bit about SMPTE standards now.
Much of ACES is actually standardized array through SMPTE. We started that process in about 2012 with the document that became known as ACES or ST 2065-1, and that's the core color encoding for the ACES system. Basically, this big bucket in which we place all of the scene referred data that Carol and Nick were talking about. But over time, we've added additional SMPTE standards. 2065-2 and -3 are both film-related standards for bringing film into the system. And then we created basically a standard around an OpenEXR image container. OpenEXR is something that's been a de facto standard for a very long time within the motion picture industry and is used heavily within VFX. But we created a constrained version of that within SMPTE as a SMPTE standard, and that is now known as the ASYS image container. Likewise, we created a standardized way of wrapping those EXRs within MXF for the purpose of ultimately putting into an IMF package, and that's known as IMF Application 5, and that's specifically for delivery and archive. Other aspects of the ASYS system will be standardized through SMPTE and be given appropriate SMPTE standards numbers. There may also be some recommended procedures and other documents within SMPTE, but we're constantly working on these standards and evolving these standards. And in fact, a number of the standards have recently undergone revision for the purpose of prepping them for delivery to ISO. So many of these standards will also become ISO standards for sort of greater international significance within other countries. Yeah, back to Nick at this point, right?
Yeah, so thanks, Alex. Here's a block diagram of the basic elements that make up an ASYS workflow. And if we go through it and look at a few of them in a bit more detail, the first thing is the input transform, which you'll often hear referred to as an IDT. This is the first crucial step of the ASYS workflow, because when you're starting with all these different sources that have their own encoding formats, they all need to be transformed into the ASYS 2065-1 standard. And that's what an input transform does. They're created per device, and camera manufacturers are encouraged to publish the colorimetry information from their cameras and create input transforms. That doesn't necessarily mean it makes all cameras look identical, but it does greatly simplify the process of camera matching, because they're brought into this unified working space. And when you have a range of cameras on a show, which is pretty much always the case these days, isn't it? Your colorist gets a start point of having the cameras closely matched to start with, and then they just need to tweak them to get an exact match. So as I said, the camera manufacturers produce IDTs, and I think ASYS has been a big driver in getting information on the colorimetry of cameras out there and available to be used even by people who are not using the full ASYS system. All the major camera manufacturers have input transforms published in the ASYS GitHub repository, and those are there to be used out of the box in every application which supports ASYS. And the information is there in the ASYS documentation to help other camera manufacturers produce input transforms. In fact, there's an ASYS working group meeting regularly at the moment to devise ways of making IDTs more easily and more consistently, particularly to help smaller manufacturers of drone cameras, crash cameras, and so forth that don't yet have ASYS IDTs available.
Yes, so ASYS introduces this concept that we call working spaces. We support a number of them, and in fact, in some custom applications, we can actually support any working space you would like. But the main idea here is that the ASYS 2065-1 color space is great for the purpose of interchange, for collecting camera data and passing that around. It's a big container, but it may not necessarily be optimized for applications such as DI color correction or VFX. So we've introduced a couple of additional color spaces that we use for those particular applications, such as ASYS CCT for DI and ACES CG for VFX. These are just optimized color spaces to work with the tools and with the workflows in those particular pieces of the overall pipeline. For instance, ACES CG is a linear color space that has a smaller set of primaries known as AP1, and there's a picture of those on the right-hand side. AP1 is it's a much better color space for doing lighting and compositing than AP0, which holds lots of information, but can do some strange things if you do particular operations in that space. The DI color space, ACES CCT, there is an ACES CC as well, but ACES CCT is great for doing color grading operations. Color grading systems typically expect the data to be in much more of a perceptual space than ACES 2065-1 is. So it's much more logarithmically spaced, for instance, in terms of luminance. And the DI color grading systems won't necessarily react well if you tried to color grade on ACES 2065-1 directly. So you can transform your data into ACES CCT, do your color grading, and then when you go to hand that off to somebody else, you can transform it back to ACES 2065-1. So that's a touch on the working spaces.
So yeah, without proper color management to show with a whole bunch of different cameras and a bunch of different deliverables required, we'll have to create a plethora of permutations of a show LUT to go from every source to every destination, what Carol referred to as lost in LUTs. With ACES, you use what's called a look transform, or LMT, and you only need one look transform for your show, or at least for a scene, if that has a particular look to it. Because it is applied to the ACES image data, it's applied after the input transform when everything has been brought into this common working space, and it's applied before the output transform when it has been converted to the required display space. So the same look transform will create the same perceptual aesthetic appearance from all the different cameras and on all the different display devices. Then we come to the output transform. The ACES GitHub repo contains output transforms for a range of display devices, Rec 709, PQ, DCI projectors, and so forth. And these are available, as I said, out of the box in systems which support ACES. These are the main types of display in common use. And that's the idea. You don't use an output transform for your specific display, you use an output transform for a class of display. So you don't have to create a custom output transform for your display. Your display should be calibrated to one of those standards, and then the output transform you use is the one for that standard. Though because the maths is publicly available, it would be possible to make a custom output transform if necessary, if you had a non-standard display in some kind of installation or such like. But everybody working on a show monitors through an appropriate output transform for whatever display they're working on. So they all see the same thing. And then when you render deliverables, you render them through the appropriate output transform. But your grading has all been done on the ACES data. You just make the output deliverable through the output transform for that class of display. I wouldn't say that you should do a grade on one standard of display and then just immediately flip output transform and render something out and say, yeah, that will just work immediately on another display. But it actually does give you a very good start point. I know people who have graded a movie on Rec 709 in their own small studio and then just booked a small amount of paid time in a bigger facility that has a P3 projector, use the appropriate P3 output transform there and trim the grade and check it before delivering a DCP.
So delivery and archive, we talked a touch about IMF IMF-APP5 during the standards portion of this. But IMF-APP5 is a great way to deliver and archive your show. Basically what we do is we take these ACES 2065 individual OpenEXR files, wrap them up within an MXF, and then take all of that and place that within an IMF container. The IMF also includes metadata essential for recreating the pipeline to describe how it is that those images should be displayed. So it's a critical aspect of the overall ACES system. This is a fairly new piece of technology that we implemented a few years ago and standardized within SMPTE. But there are a number of pieces of hardware and software out there already that support IMF-APP5, and we highly suggest creating IMF-APP5 packages for inclusion in the archive.
Great. So who benefits from using ACES for their color management? Because you've learned a lot now so far, kind of filled your head. So just wanted to kind of sum up how ACES is used. So any production that uses multiple cameras, for example, and or uses a lot of multiple vendors like VFX vendors can use ACES to basically make sure that their color and file format exchanges are consistent and reusable. So to give you an anecdotal example, I used to work at Marvel Studios, and a production there could easily have over 15 different VFX vendors. So ACES made a lot of sense there because it provided a known standard format and way basically to interchange with all of those VFX vendors and to get the returns back from those vendors in a consistent manner so that you knew exactly what the color was in those files. Plus, if you wanted to reuse a scene from one movie in another movie, you knew exactly what the color was in those files without having to trace the color path of those. ACES is also great for companies like studios, for example, like Universal Pictures, for example, because we have a lot of different types of movies. We have low budgets, we have tent poles, we have everything in between. But we just want a consistent color pipeline and archive for all of our productions, because when we want to go back to it later or whenever we're actually in production and we just want, you know, a seamless way of knowing what's in our files, ACES is a great way to provide that. But ACES doesn't have to be just for live action tentpoles. Smaller productions like documentaries, for example, or even animation, actually, doesn't have to be live action. Can definitely benefit from ACES because it simplifies the color management that's needed on the production, meaning that you actually don't have to have a color scientist on staff. And it also allows you to maintain the widest dynamic range in your images, even though you don't have a color scientist there. So hopefully that helps. This section helped explain the components of ACES and why you would use them. Joel, do we have any questions for this section?
We do, and we actually have an oral question from our guest, Walter. And Walter, you have the floor.
Okay. Hi, everybody. Hi, Nick. Hi, Alex. How you doing, Walter? Hi. I think you guys tend to oversimplify the ODT aspect of it. I finished the whole guard. There was an entire ACES process. And because we are in the pandemic, we have the necessity to do a 709 master first, because the only thing we can do streaming. Once we have a proper tonal range and a proper master done in 709 and we switch to HDR, what I see is the aggressiveness of the tonal range of HDR, the ODT, the RRT ODT, that I have to undo just to be able to rebuild the same tonal range the client asked for. In other words, I found ACES, yes, you have ODT, they give you starting points, but don't match what was the intended deliverable that we actually approved. How do you deal with that?
Obviously, SDR and HDR are different formats and capable of different things. So if the roll-off of the highlights, the smooth roll-off of highlights in the SDR version is a crucial part of the to an HDR output transform is going to want to make use of those higher brightnesses available in HDR. So if you actually want to rein it in and make it not do that, that's where a look modification transform, LMT, can come in, and you can create a look transform that you apply across the show that deliberately limits the HDR range. So you're not, you could actually make a look transform that emulated the look of the SDR deliverable within the HDR. So it prevented it from using those higher parts of the HDR range. It applied a roll-off deliberately.
Yeah,
does that make sense?
We like to refer to this sort of as intent. The capability of HDR is so much greater than the capability of SDR, but you may not necessarily want to take advantage of all of that capability that's there within the HDR display space for every given show. You may want to take advantage of some of it, but not all of it. You may want to rather than express more of the scene content on the HDR display, simply use more of the brightness of the HDR display. And we kind of refer to this as sort of the intent of the conversion from the scene referred space to the output referred space. This is something that we're thinking about as we go to ACES 2.0, how exactly we can make this more obvious to people and make this a little bit more approachable. But it's something we do hear about from time to time, particularly when people start with an SDR grade and then want to get a very similar looking HDR grade.
And I should also mention too, we are going to talk about this in the next section, but you're absolutely right. We don't want to sugarcoat, how, ACES is so perfect right now. If it was perfect, we wouldn't be having this next bit that I'm going to actually discuss, which is our ACES next efforts. So I'll talk a little bit more about what we're going to be trying to do, because we do want to make it easier. It's not necessarily something like we just said that it's like a perfect solution and very easy to implement right now, but we're going to try and work on that.
And we have many, many questions building up for our Q&A period. So if you want to proceed, let's go.
All right, thank you. So now that you know the basics of ACES and color management, let's talk a little bit about how ACES is structured right now. Thank you. All right, so originally there were a lot of really smart people that came together to figure out what ACES version 1.0 should be. However, it was commented that this seemed like a closed academy project and not an open community project, which made the development process and decisions seem not as accessible to implementers and end users. So when Rod Bogart and Jay-Z, who are my vice chairs, and I took over the reins for ACES, we conducted a listening tour to find out what improvements were needed to make ACES better. And we heard people loud and clear. So we basically embarked on this next phase, which we call ACES Next, where we give more oversight, development, testing, and implementation responsibility to the broader community. This includes engineers, end users, and stakeholders who use the system. So we created a new organization, which is actually shown here on the right-hand side. So ACES leadership includes Rod, Jay-Z, and me, and then the Academy staff like Alex. And then we have 2 technical advisory councils, or TACs. We have one for the architecture side of things, which focuses on designing features for ACES, and one for implementation, which focuses on implementation issues. The TACs basically help provide guidance and governance to our working groups. Under these TACs, we have various working groups which focus on solving specific problems. The working groups are open to anyone to participate in, so we welcome your involvement in any of these that strike your fancy. Joel, can you go to the next slide, please? So just to explain sort of the versioning of ACES. So currently we're on ACES version 1.2, which was released in April of this year. This release includes a new version of the Common LET format, or CLF, and ACES metadata file, or AMF. We are now setting our sights on ACES 2.0, which is meant to delight the industry with its ease of use and features. We will basically have a few things. Here's a list of them. I'm not going to go through all of them, but the major ones are that we have a new, more neutral output transform that will actually, I think, make things a little bit easier for people to utilize for different display devices. Much better gamut mapping. So gamut mapping is when you go from one color gamut like AP0 to another color gamut like AP1, as Nick and Alex had talked about. And other improvements that you see listed here. We are also aiming to have a staged approach. So we'll probably have an ACES 2.0 and then have a 2.1 and a 2.2, et cetera, so that we can roll out new features as they become available. And of course, because we're making these updates, the ACES SMPTE standards are going to have to be updated. So the right side of the slide shows the various working groups that are happening as of now. All of these groups are very active and have regular meetings. The AMF and CLF groups are working on implementation activities, while the Input Transforms group just kicked off, I think, about a month ago. The Gamut Mapping group, which Carol is a co-chair of, is in full swing, and we will be starting the Output Transforms and Compression for VFX workflows working groups very soon. All right, so I've talked enough. So Alex is going to talk a little bit about the ACES logo program and community.
Yeah, so we have this ACES logo program, and there's actually two tiers to it. The second is just sort of ramping up at this right now, but the primary portion right now is the ACES Product Partner Program. This is intended for hardware and software manufacturers. We currently have 31 members signed up who plan to implement ACES within one or more of their products that they make. Now, this is specific to individual products. So individual products are given the ACES logo, not the company as a whole. So you'd have to contact each of the companies to figure out whether or not the product that you're interested in is logoed for ACES currently, or is on a path to be logoed for ACES. Likewise, these 31 companies may or may not have a logoed product at this time, but they intend to within some reasonable time frame in the future. And these companies are across a vast number of categories that we've set up. There's camera manufacturers, on-set color correctors, LUT boxes, displays. So they all have their own specific set of requirements based on the type of product that is being logoed. The service provider tier is something that's new and it's coming soon. So we're working with VFX, DIs, daily facilities, basically vendors who are producing deliverables for you while you're creating your show to help qualify them to so that you know that your show is being handled in a way that is compatible with the ACES system. For instance, if you were to ask for an IMF App 5 package from your logo qualified service provider, they should be able to give that to you. But that is something that is coming soon and just ramping up right now. But the product partners, there are a number of product partners out there already, and a number of pieces of hardware and software from those product partners that you can get today. So the place to talk about ACES is definitely acescentral.com. acescentral.com has all sorts of resources for the general community to find out about ACES. There's a great set of quick start guides. There's a knowledge base full of FAQs. And likewise, we have links to the working group homes. So all of the work that the working groups are doing is public and discussed within the community section of ACES Central, which is a forum. So if you go onto community.acescentral.com, you'll see that there's a forum there, and people are discussing ACES all day, every day. Sometimes it's a lot to keep up with because there's so much discussion about ACES right now within the community. Like I said, the working groups are primarily discussing their work on there, and the working groups are something that anybody can join. All you've got to do is look at the calendar, which is available on ACES Central, and just see when we're having a meeting and join the meeting and either listen in or participate, whatever you're comfortable doing. And if you've got a problem that you think needs to be solved by ACES, you can discuss that within acescentral.com and in the community. And if it's something that really is a gap, you can just fill out a form, a working group proposal form that suggests forming a new working group, the problem that needs to be solved, and ACES leadership will take a look at that and if appropriate, form a working group. You're not necessarily committed to being the chair of that working group if you submit a form, but the community drives where ACES goes. And if the community sees a problem, we want to know about it so that we can appropriately address that and get the right people together to talk about the problem and find a solution. So I would highly suggest everybody here join acescentral.com and get involved in the process, because this is a community-driven effort.
Yes, I completely agree with you, Alex. Thank you. Joel, next slide. This is our last one. I just wanted to touch on the use of ACES in broadcasts. Since we do get that question a lot about whether ACES is appropriate or not broadcast. And like many things in life, well, the answer is it depends. But we can use your knowledge now that you just learned in this webcast. Basically, if you are doing something that is a scene referred workflow, like something for episodic content or any content that is shot and then basically put through a post-production process, you can probably use ACES for that production. However, if you're doing live workflows where the cameras are shaded first, and then you're basically going through a display referred workflow, then that is questionable about whether you would get any benefit from ACES. Plus, you would also need to have equipment, as we mentioned earlier, that is ACES capable for that workflow. But we have had conversations about broadcast, and some people are interested in trying ACES for live use. So there is more to come in the future in this area for sure. All right, so now I'm sure there's a lot of questions, Joel. So I think the panel is probably going to turn into more of a question answering thing. But yeah, if everybody could just turn on your cameras again, and then we can take some questions.
Great, thank you very much. And as a reminder to our guests, although I don't think you really need a lot of reminding based on the number of questions we have, just type in your question if you don't have a microphone or you prefer not to ask an oral question, or if you would like to speak directly to our panel of speakers, just type in, I have an oral question. You go to the top of the list and I'll unmute you. Let's see. First question is for Carol, and it's from Abe. It says, if we map to wide color gamut today, but get bigger in the future, will we have the same problem as legacy sRGB?
No, and thanks for the question. It's a good one, and I totally think that I get where you're coming from, and I think anybody would say this thing, but the way that ACES was defined is that ACES 2065-1 is a color space that it covers all the colors in the visible spectrum. So theoretically, unless our eyes change significantly, there won't be a display technology that we ever have that is wider than ACES. So that's one of the reasons ACES is defined the way that it is.
Okay, thank you. Let's see, from Vishnuharan, what is the difference between ACES and linear image from the CGI image used in VFX?
Well, ACES, the ACES 2065-1 image format is a linear image, but it's a linear image with a specific set of primaries. So the AP0 primaries, as Carol was just mentioning, cover all the visible colors, whereas their legacy VFX linear data, people tended to mean when they say linear, they mean by default sRGB linear data that uses the sRGB primaries, which is a much smaller triangle within those visible colors. But actually, it is a default because when you say linear, you're not specifying. When you talk about your image data being linear, you need to specify what the primaries of it are. And the AP0 primaries contain all the colors, but the AP1 primaries, the working primaries of ACES CG, are also very good primaries for rendering CGI in. They, if you render in sRGB linear primaries, you get a less accurate representation of the behavior of light in your 3D software, because in your compositing software, because you are working in this more restricted triangle of colors.
Yeah, likewise, ACES is an entire system which describes how to get into and out of that ACES linear color space. Where if you're just working within VFX software and you ask for a linear file out, you've got no clear way on how you're supposed to view that file for any specific device. Obviously, people view these files, but they're usually viewing them with a LUT, and that LUT's built for one specific set of circumstances. And then you get into sort of the LUT hell that Carol was talking about at the beginning, where ACES is a framework for color managing your way into and out of this linear color space.
Thank you very much. And Greg reminds us about the ACES Quick Start guides on acescentral.com. Just wanted to mention that. And let's see, we'll go back to the top of the list here. For Dean asks, for offline editing, any changes to the process of ingesting or editing? You mentioned a specific company in mind.
Tricky one. The NLE companies are starting to move towards ACES. Avid do have some elements of ACES incorporated in their products, but at the moment, for editorial, it's often simpler to bake in the output transform for whatever your editorial is going to be done in, and that's likely to be Rec 709. So what most people are doing at the moment is baking a Rec 709 output transform into their dailies and using those for editorial and then matching back. So I don't know of people generally doing editorial in ACES, but it will come.
Yeah,
it is coming.
Sure.
And,
it is coming.
Yeah, new bits from Avid support ACES, and they really, in some ways, move well beyond what a traditional editorial system would normally do for color. So we're in an exciting time for editorial, I guess, is the point.
Good. Let's see, from Vivek. Can we grade ACES with output transform to 709 and take a delivery for Rec 2020 HDR in the future?
So I guess yes, that if I'm interpreting the question correctly, that is fundamentally what grading in a scene referred space does for you, is as long as you archive your content for ACES, for example, then theoretically, if you wanted to go back and output in another delivery space later on, even when your content was only mastered for 709, as long as you follow the ACES workflow and work with your grades in a scene referred space, it should be not automatic, but relatively trivial to output for a wider container of your display.
But yes, you don't make the HDR remaster from the SDR remaster. You go back to your ACES archive, and that's what the ACES archive is all about, preserving the original and the creative intent of the first mastering process, So you have that as a reference, and you can then use an HDR output transform, and you get a good start point. But as Walter, I think it was asking earlier, obviously, if what the switch of output transform does isn't what you want, you can trim, but it should only be a trim. It does make it easier.
Next question is from Josh. Why would I choose ACES over a specific vendor's color management system?
I mean, I can talk about, you know, and again, at the end of the day, I'm going to say that this can be a personal choice. There's the different vendor management solutions out there. A lot of them are fantastic. I've used them, and they're great. The main benefit that I see to ACES, one of the main benefits, is that it is open source and that it is available for anyone to use at any time. It is an open standard community development driven by the people that are using it. And I think that that's really powerful. And while the vendors do a great job of listening to their community, it isn't exactly the same as an open standard where you can go and look at the math and how it's done and these standards and use it on all of your productions. Even if you don't want to use the same software, if you've got lots of different productions going at the same time and some are using different color grading applications, how do you standardize and how do you handle that? And how do you keep it consistent across all of your different productions that you have going on? I don't know if anybody else has other thoughts, but.
No, I think it is the available, the same everywhere aspect of ACES that is a big selling point for it. Because yes, if you're only grading on a particular system or only shooting on a particular camera, then grading system manufacturers and camera manufacturers do have their own scene referred workflows. So ACES is not the only one, but it's a standard and ubiquitous one.
Yeah, I'll just say that for the archive, it's very helpful to have something in the archive that's standards based. We hope all these companies that are in the industry today are going to be in the industry 150 years from now. But the fact of the matter is we don't have that guarantee. Where we do have a guarantee that standards will be around and will be referenceable far into the future.
Okay, next question. It's from Nick. When choosing a reference monitor, does working in ACES require an HDR monitor? What are the display requirements to color in ACES?
No, I mean, as I gave the example in my section of the presentation, if you're working for a 709 deliverable initially, you could work for Rec 709 in ACES with a Rec 709 monitor, and then at a later date, if you're asked for HDR, I mean, obviously, if your deliverable requirements specify you need to provide HDR, then ACES isn't going to magically make you not need an HDR monitor to view it on. You can't deliver something you've never seen. But at the stage where you're only asked for Rec 709, you only need a Rec 709 monitor.
Thank you. Let's see. CFAS, what is the bit depth of ACES and how is it different from HDR19 or Dolby Vision? Would that be HDR19 or HDR10?
Probably HDR10.
I assume.
Yeah.
So I'll start off with the easy part and then the smarter people will take over. So the ACES EXR container is a 16-bit half float. So there's plenty of information in that container. And HDR10, again, keep in mind that's more of a display referred type of color. But typically and HDR10 is actually a 10-bit. But there are higher versions of HDR before you actually squash it down to an HDR10. And I don't know if Carol or Nick, if you guys want to, or Alex want to add anything else.
Yeah, I was just going to say it's important to recognize the fact that we're talking about bits in a different part of the system. So these are scene referred bits versus output referred bits, where when you're talking about HDR10, it's 10 bits output referred. And when you're talking about Dolby Vision, they're usually talking about 12 bits output referred in that part of the system. Those are display bits as opposed to scene bits. So it's not exactly an apples to apples comparison.
Yes,
Great,
and
thank
hence the
you.
reason why we were trying to cover in color management what a scene referred workflow is versus display or output referred workflow, because it is very key because the bits are different.
Thank you. Simon has a couple of questions. Let's see. Using an HDR output transform doesn't mean you can just use that for the for HDR, does it? Presumably, you have to do some grading adjustments for an HDR grade as well. He also goes on to say, many thanks for the session, by the way.
Oh, that's nice. Thank you. I'll take that real quick. So yes, I think the idea, the path that you would want to take is like you usually have a hero grade, right? So you start with something, whether it's the SDR grade or the HDR grade, whichever one is your hero. And then the idea is that you would change out output transforms when you go to your next display device that you want to go to. And then do a trim pass on that. That's typically, I believe Nick actually covered that earlier, is that basically the output transforms give you a good starting point for those different display technologies. But what we do, at least on the feature side, is that we would then do a trim pass to optimize it even more for that specific class of displays.
And yes, ACES doesn't remove the necessity for grading. It gives a starting point before you grade that is intended to be neutral. So unlike looking at a camera log image, which is not intended to be viewed at all, when you view through an output transform, you do see an immediately watchable image, but no, that doesn't have any creative intent into it. That's up to you.
Well, and I have heard of people that just change out the output transform and then they're done. So that is totally possible. It's really up to you as the creative, what you want to have in your image. But I think most people will do a trim pass.
Let's see. Next, I'm going to group two of Mariana's questions together because I think they're related. She says, I work in a VXF facility, and we want to work all our projects in ACES. What is the appropriate way to transform the EXRs from whatever color space our client is using to ACES CG? And she goes on to say, for VXF, if the client sent us the EXR in ACES CCT, how can we transform from CCT to CG so we can work?
Yeah, there's a lot there, and you're hitting at the meat of sort of what I was talking about at the beginning of color management. But what ACES does provide for any, we call it, what Nick was talking about is the input device transform, and that IDT, and color space transforms defined to go from all of those recognized ACES inputs to the ACES color space. A lot of VFX houses utilize a tool called OpenColor.io, which comes natively in a lot of the VFX applications that you're talking about. And that comes, and so like Nuke, for example, ships with an OCIO configuration file that has ACES transforms that are publicly available and built and verified by the community to get your data from most known input color spaces into ACES. We can talk offline or things like that and reach out to us on ACES Central or on the OCIO mailing lists for more information, and we'd be happy to help you walk through that, because it's not something we can answer for every situation in 5 minutes.
And I just wanted, I'm sorry, I made a little grimace at the end of that question, and it was just because, when the files that you want to interchange are the ACES EXRs with the AP0 linear information in it. You don't want to move around files like ACES CCT, for example, because those are actually log files that have less dynamic range and less information in them. The ACES CCT, CG, and CC are all working spaces, so they're never meant to actually deliver to someone downstream. I have heard of people doing that, and that's why I kind of grimaced there earlier, because I was like, no, please don't do that. So just make sure, you want to make sure you have the widest dynamic range in the files that you're working from. So you want to make sure you are actually using the ASUS ST2065-1 files sorry, -4 files that have all the good information in them, not just something that's already been converted to log.
And generally, as a matter of principle, you shouldn't put log data into an EXR file. It's a file format designed for linear data, and it's optimized for linear data, and you are actually losing something if you put log data into it.
The great thing about it, though, is that in a lot of circumstances, and we are all aware that we get different things on different projects that we can't always control. But the point that we can drive home, though, is that as long as you stay in that scene referred space, so in a camera encoding space or in an ASUS space, that you're going to be able to get non-destructively between those spaces without a ton of compromise to your data. It's only when you get to the other end where you have data that's already display referred and trying to get back out of that you really run into issues. So a lot of it is just doing your best to keep your workflows as wide color gamut and scene referred for as long as possible and as much as you can control.
And that's an important point you made there, that the camera encoding spaces are scene referred in themselves, and the transforms from those to ACES are published in the input transforms. So you don't have to turn everything immediately. You don't have to turn all your rushes into EXRs, making a huge amount of storage requirement. You could work from camera native files, and the transforms into the ACES space can happen in software as you work.
Okay. We have about 17 minutes left for questions, and we still have quite a few. Let's see, next question comes from Brad. Brad asks, what charts, if any, are you using as a reference reflective surface to ensure visual color reference is maintained through the process rather than just relying on transforms?
So I don't know if you're talking about, so maybe you're talking about having an extra safety step of shooting a color checker chart on set, and then running it through an ACES pipeline and making sure that the values are coming out as intended. That there's a lot in that question, because what values are in ACES versus like linear sRGB versus a display, they're not the same. So it depends on what you mean by, we obviously have records and standards and consistency of what those color checker 24 values should be in ACES, and those are publicly available, and actually getting an update in this SMPTE revision. So those are publicly available if that's what you're asking, is how to track the values of that color checker chart through the process.
Okay. Let's see. Matt asks, when you say CG or CCT are optimized for those use cases, could you expand on that? Is it for system performance or more of a practical conceptual optimization?
Should I take that one? It's not system performance. It is about the way the maths works. I mean, when you're working in CGI or compositing, you're simulating the behavior of light. If you composite something over something else, or if you're calculating reflections in CGI, you're simulating the behavior of light, and light is inherently linear. So when you multiply values together or add values together, you want those to be linear. So the maths works correctly to simulate the behavior of light in linear. So ACES CG is designed specifically for that. So no, it's not about optimizing. And the ACES CCT as log is slightly more complex. That's really because grading systems have historically been designed to work on log data. So the mathematical operations that grading systems apply were designed for log data. So the way they respond, the way they feel to a colorist moving the trackballs around is familiar to colorists from working on other logarithmic data like Cineon scans or like camera log encodings. So ACES CCT will feel the same, but just the underlying math that grading systems apply is designed for logarithmic encodings. It doesn't have to be. You can make the user interface logarithmic and the underlying data can be linear, but the way things work with traditional grading operations just works properly on log data.
Thank you. Clark's question is an ODT the same as a DRT?
DRT is
display rendering transform.
Correct.
That would, yeah. Is that okay?
Conceptually,
conceptually they're the same thing. Yeah.
But technically, a DRT is more like the RRT, which is a subcomponent of the ACES output transform. There is, and it's probably getting too deeply into the nitty-gritty detail for a 101 course, but there is a global rendering transform that's applied to the ACES data that does the bit that just takes it from scene referred but to a generalized display referred space, and then a second part that transforms it for the specific class of display. And Baselight uses what they call DRTs, which sit somewhere in between the reference rendering transform and a whole output transform. But conceptually, yes, they're doing the same thing. Baselight applies DRTs when you go from a scene referred space to a display referred space, and that's what output transforms are doing in ACES.
Thank you.
Indeed, Baselight has DRTs, which are the ACES output transforms. They just have other ones as well.
Yeah, and I think there is just some terminology confusion because we are now referring to the what used to be the RRT and the ODT together now as an output transform, as opposed to splitting them up into the separate components they used to be. So that there is a little bit of a transitional knowledge change over here. So the ODT was one of the components of the output transform, but now we're grouping the RRT and the ODT together. RRT is the reference rendering transform, ODT is the output display transform, and now we're just simplifying it and just calling them output transforms.
Thank you very much. Let's see, Coleman. Says, can ACES produce dynamic metadata for IMFs? He did say specifically like Dolby Vision.
Yes. No. It's not meant to do that. You would, for example, in the Dolby Vision example, or maybe like an HDR10 Plus example on the Samsung side, you would actually have to run a separate process to get that Dolby Vision data, or not a separate process, but I mean, it's done during that trim pass for Dolby, and then the HDR10 Plus is a separate pass. But the ACES process is not meant to create that sort of proprietary dynamic metadata. That's just a separate proprietary thing.
Thank you.
Sorry, Gil, I should mention that. But obviously, you can start with your ACES data and create the Dolby Vision pass or the HDR10 plus pass. Blah.
Yeah, that's what I was just about to say, Annie. It's not that they can't work together. It's just right. The ACES system. I mean, that's sort of an add-on that a manufacturer would have to support.
Right. You just think of ACES as the bigger, greater space that has all of this, wonderful data in there, and then you have all these different pathways that you go down for HDR and then SDR, projection, and for consumer displays, that sort of thing.
Great. Let's see. Victor asks, what happens with the color values that remain out of the AP1 in DI color correction?
That's a fun question. What happens? Many different things can happen, and values, outside of AP1, which is the color primaries defined in both ACES CG and ACES CCT, happen for lots of different reasons in lots of different places, both as far up in the process as transforming to ACES from a camera encoding space to values created possibly, in your VFX process, to things you do in the as a colorist. You you're trying to get a certain look and you turn a knob and it gets out of gamut, is what we call it. And what happens to those values is they is a lot of different things. One, that if they're out of gamut, depending on the display space that you go to, they're just not, it can cause lots of problems, I guess, is the baseline thing. Sometimes it doesn't, and sometimes it does. That is the basis of what we are trying to adjust in the gamut mapping virtual working group that Matthias Scharfenberg and I are co-chairing, along with the great help of Nick. So it's a topic very close to our hearts, and I don't know if there's a lot we can get into right now until actually your question of what happens is pretty deep. But if you're interested in learning more about that, please come to our meetings and check out what we've done so far.
And I would say it's important to say that something that is outside of the AP1 gamut, when you transform to a working space that is based on AP1, that isn't clamped. We don't clamp to the AP1 gamut, but it will produce negative values. An out of gamut value produces a negative AP1 value, and that's where then gamut mapping algorithms that Carol was talking about will try and help with the problems that are caused by having negative values in there. But if you transform to AP1, the negative values are preserved. You transform back, if you do nothing there and transform back into AP0, it's all preserved. It still exists in the image data. You're not clipping to that gamut.
It's a good point. Thanks, Nick.
Okay, next question is from Utsav. Let's see. How does ACES work with LED screen-based virtual production?
In the same way that it would work with any other display that you're trying to go to. ACES would consider whatever the specifications of your LED panel to be a specific output transform. And what that is or what that looks like depends completely on your system. But the workflow theoretically would be the same depending on your use case for what you're doing with the LED panels. It would be working on your data in a scene referred ACES working space, doing whatever you need to do, and then sending the output to the LED panels with the correct output transform at the end of the pipe that's meant to be displayed on the panels. It's a very up and coming question and very relevant right now.
But obviously, if you're talking about the virtual production where you're actually having the LED panels in camera, the intent is that those panels should be calibrated so that they produce the scene referred values in the camera that would have been produced had the real scene that you are trying to represent on that panel existed in front of the camera. So there's a lot of complicated profiling of the LEDs goes on to try and make sure that there is a match between the camera and the panel.
Yeah, it's definitely not your.
Can't tell the difference.
Yeah, it's definitely not your default output transform. That's for sure.
Okay, we have a little over 5 minutes for questions. Let's see. Mekades asks, how different is the ACES color space compared to the other standard color spaces? For example, from CIE Labs in terms of perceptual uniformity, dynamic range, and channel independence.
ACES is an RGB space, so it's different from CIE Lab in that sense. It's not, because it's not intended to be a working space that is perceptually uniform. It is a way of representing the visible colors.
Yeah, absolutely. Those spaces have very different purposes. C-Lab, again, is intended to be sort of a device-independent, perceptually uniform space. ACES is device-independent, sort of. It's actually device-dependent relative to a theoretical camera. But that's kind of getting into a lot of very specific stuff. But it's certainly not perceptually uniform, and that's not a ding against ACES. It's just it's intended for a very specific purpose that's different than the specific purpose that C-Lab was created for. Likewise, other spaces that would sort of be similar to C-Lab might be like CCAM UCS or JZAZBZ or all sorts of weird spaces like that.
Thank you. Let's see. ED. Usually AP1 is not big enough or possible to choose to work in a bigger working space. Is it possible to choose in a bigger working space, maybe in future versions?
You could do that right now if you wanted to. I mean, theoretically, it is 100% possible to work in AP0 in ACES 2065-1 in a linear encoding. So if your application is VFX specifically, you'd be set up to do that. If your application is more towards the end of the pipeline in color grading, you're going to run into some of the things that Nick was talking about in that the tooling isn't designed to work that way. But theoretically, we'd love to hear about your instances that you're running into where AP1 isn't wide enough. That's really interesting. So if you'd like to reach out and give us some examples, we'd love to hear them. On ACES Central is a great place to do that. But technically, theoretically, there's nothing stopping you from working in ACES 2065-1 today.
And you can go to other working spaces, as we mentioned before. I mean, we've had a lot of talk about ACES CCT and ACES CG, but we do know of productions that have gone to, for example, like area-wide gamuts for log-C, or other more proprietary working spaces. So there are ways to transform from ACES into those spaces and back out again. So. I'm not sure if that answers her question either.
Yeah, in general, ACES is a framework, and that framework is in a lot of ways intended to be extended upon, whether it's adding dynamic metadata for Dolby Vision or using additional working spaces for very specific purposes, or creating output transforms for, I'll put in quotes, weird devices like LED panels. It's a standardized framework that is intended to be extended upon by the community and by its users, and that's a lot of where the power is within ACES. Okay,
we have 1 minute left and much more than 1 minute worth of questions. So I'm going to ask this one. This will probably be the final one. Could someone speak to scanning from archival film, particularly prints, if no negatives exist? I know this is probably a small niche need these days, but as an archive, we're very interested in ACES potential. The last thing I was aware of was that ACES specific transforms would need to be generated by film manufacturers to be compatible with the ADX encoding. Has there been any further investigation and or outreach in this area? Okay.
I'll try to answer a little bit of it, and then Alex could maybe jump in too as well. So we actually are, I am actually trying to work on a proposal for another working group to actually relook at the way we take film into ACES. The original process was that you needed these things called ASAP calibration rolls to calibrate your scanner before you scanned in the film. But those would have to be specific to the film stock that you're scanning. And so for restoration workflows, obviously you're not going to have film laying around with these calibration patterns from like the 50s and 40s.
Yeah, I would just say that actually pertains to film negatives. Prints is a completely different process that we should talk to you about as well, because it's very different. It's much more similar to bringing in output referred material, such as Rec 709 footage or something like that, something that's been pre-finished. So it's a very different process and a very niche process, as you mentioned in the question. But it is something we can talk about with you and help you work through.
But it's true. I heard him say the word prints, and I forgot about that part. But thank you, Alex.
And that is really all the time that we have for questions. We do have this one last slide for you folks.
And thank you. Oh, yes. Yes, please. As you've heard throughout this this webcast, please, if you have any more questions, you just want to chat about things with ACES, please come to acescentral.com. If you sign up, it's free, it's easy, and you can see all of these other postings that other people have done in the threads. But you can start your own conversation there as well. We'd be happy to answer questions there. So yeah, let's continue this conversation. And thank you very much for spending the time with us.
Absolutely. I would like to thank you, Annie, Carol, Nick, and Steve even. And let's see, who did I miss? Alex, for presenting this and answering some tough questions. There are a lot of people saying thank you very much. And for those folks who we did not get to your questions, please go to acescentral.com, and I'm sure that they will be able to answer those questions for you. I'd also like to thank all of you for participating. I think we topped out at about 415 attendees, but 950 something registrants. But anyway, it was well worth the time. I also want to thank our sponsors today, VizRT, AJA Video Systems, and Signiant. And then it's their support that allows us to bring these webcasts free of charge to everybody. So thank you to our panelists, thank you to our guests, thank you to our sponsors. Take care, please be safe, and we'll see you next time on a SMPTE webcast.